Sweet. Would you be able to just check in on that? G'day everyone. Welcome. Thanks for coming along. Tonight we've got Iska. He's doing a talk on water meets metal. So very excited to learn a little bit about metal APIs because I have no idea how they work at all. So yeah, should be a really interesting talk. And before we get into that, we're also going to have Gotham. He's going to do a bit of a dub recap. Obviously, dub was last week. So yeah, he's going to walk us through the highlights of that, which should be awesome. Just a bit of housekeeping. Toilets to the left of the kitchen, just straight through there. And then fire escape, also same place, just straight through there. Keep going down the stairs and make it to safety. Thanks Intane, they help out providing the venue here and the cleaners and all of the IT guys providing this gear, so big thanks to them. And also thanks to Mantle because they provide the food and they also provided the AV gear so we can share this with people on YouTube, which is awesome. If you're new here, you can find us online. We encourage you to join the Slack channel. That's where sort of a lot of the communications can happen. There's great network on there. So if you're like looking for jobs, you've got people who will post up jobs. If you're stuck on a problem, there's people that can help with a problem if Claude can't help you. And then obviously there's the meetup as well, which is probably how you find the event today. Upcoming events. Yeah, cool for anyone if they want to do a deep dive on anything from DC. The foundational models look cool. If Gotham's going to do a bit of a walkthrough of the summary as well. So if anything stands out to you and you're like, that interests me, you know, or if you're watching online and you're from another region and want to do it remotely, yeah, that would be really cool. Otherwise, we'll just kick through the rest of the list. But yeah, we might have a potential speaker still to be confirmed, doing a bit of a talk similar to what we had last month, but more of a lessons learned around his own game dev that he's been doing. And then I'm probably looking to do one on app architecture at some point as well, just fit it in between what works for all of the other speakers. So into the AI, bit of a show of hands here, but like in terms of expectations on like how it's growing, you know, do people think it's linear, exponential, or do people think it's sort of following a bit of like a hype curve? So maybe for people that think it's sort of growing at like a linear rate, show of hands. No one? Exponential? Who thinks it's just going to keep going exponentially and just each jump's going to get bigger and bigger? Not many. And hype curve, who thinks it's following that? Wow, okay. This has actually really blew me away, to be honest, because I'm also in the latter camp there, the hype curve, and I sort of thought that from very, very early on. But yeah, the way people talk about it in the community, I honestly thought like a lot of people out there would sort of see it being exponential, to be honest. So that's really interesting. Are the cracks appearing with it now? I think like, you know, is the hype meeting reality? You're seeing all these demos, all these prototypes, you know, wow, look at this cool thing that I made in one shot. But you're not seeing so much of that actually make its way into production. And, you know, if you've got a multi-billion-dollar business like us here at Intane, I think it's $3 billion market cap or something like that. You know, we're doing a lot in revenue. Are you just going to like fire something out there, you know, with betting? Like, you know, whereas an internal dashboard, like, sure, goes good. You know, there's starting to be diminishing returns now where I feel like the models are getting less and less progressive. You know, and then now we've got the bill. The bill's the big one, I think, that with sort of people are starting to feel is, you know, when you start looking at the seat cost versus the actual usage costs, and you go, well, there's quite a big gap here, and it's probably worth paying attention to that if you're rolling it out, because the current sort of subscription rates aren't going to be that way forever. And I think, you know, if you start looking at the comparisons, I think, say, like the Claude Pro Max or whatever, like the top subscriptions here where you get 20 times the credits, I think that's around $200, but you're getting, some people reckon it's anywhere upwards of like, you know, $2,500 to $8,000 worth of actual API credits. So there's a huge subsidy going on at the moment, and that subsidy is, you know, a bit of a bait really, isn't it, to get people hooked, get them used to it, build out all your workflows and become dependent, and then, you know, you can surely trust, you know, that VC money that they're going to want to see some profit at some point. You also have the quality aspect, you know, reviewing this AI. It's great at generating stuff. I mean, one shot, bang, you got 10,000 lines, but how do you actually verify it? That's getting harder and harder. You know, there's a lot of talk around guardrails. How do you actually enforce guardrails in something non-deterministic? And you're seeing plenty of pilots, plenty of demos, but, certainly fewer are making it into production. And I think you've seen some of this recently. You saw Uber's CTO did a demo, and he pitched this, and he went to the C-level and did this great demo. Oh, isn't this amazing? Look what I did over 2 hours. And then he showed them the bill that was $1,200, and then they were like, wow, that's a bit of a wake-up call. If we can imagine this is one person, 2 hours, we've got a whole team. And I think they quickly found that out as well with blowing their annual AI budget within 3-4 months as well. You've seen Copilot now. They worked on a subscription-based model, right? And they quickly found that that's not working, and that the actual cost that they're being charged by the providers, Anthropic, OpenAI, versus what they can charge the consumers, there's a big gap. And that's why they've gone to usage-based billing. And I've heard in some companies, not naming any, but, one prompt and they're out of credits for the month. Some might get a few prompts, but, even using like very old GPT provided models, and they're churning the monthly budget just like that. So, yeah, it's interesting to see. And I think there's a bit of an arms race going on as well. There's talks of Anthropic, OpenAI, they've obviously both got IPOs coming up soon and want to impress. But I think there's also a newcomer as well as China. A lot of these second-tier models are trained on top of, the flagship US models. And some of them are performing really well and at a fraction of the cost. And I think the cost is going to be something that needs to be considered a lot more, particularly as some of who's actually funding it is starting to be less keen on investing more and more. And you see the likes of DeepSeek, with Kimi, I think 2.7, it's very, very cheap in comparison. There was a new one today, which looks pretty comparable to Opus 4.8 as well. That was GLM 5.2 that come out. That's looking really promising, and it's a fraction of the cost. And these open source models, remember that, they can be quantized and they can be run on local hardware as well. If you have the sufficient hardware, you can run that at no cost. So, you've also got the local space competing with these open models as well. So, yeah, I think there's a few more question marks sort of appearing that people are sort of starting to notice. Maybe some of the AI crazy haze is people starting to sober up and get a little bit more clarity, but time will tell. In terms of AI wins, does anyone want to share anything cool they've been doing with AI at the moment?
I can talk about what I've been building using it. It's not, I wouldn't say, it's cool, but it's been interesting to me because for the last couple of months I've been basically going full blast on Claude and getting it to build a bunch of things for me. We're building some internal tooling for a couple of for this library that's been built, and as part of that, I needed an iOS app that integrated with ESP32, both running web servers. They talk to a dashboard control system built in Python. Built in Python, and that system talks to another system built in Python. Now, a lot of that has been built with the help of Claude, and apart from that, I've also been building a separate iOS app that is used by librarians to sort of, I guess, stay on top of the status of everything inside the library, and that's a bunch of screens corralling a bunch of data. And what's been interesting to me is actually how good the quality, the output has been. Essentially, I've been using, I was using Opus 4.7. I'm now using Opus 4.8. I was using Fable for a few days. And I guess the thing that I found really interesting is that it's not only good at generating stuff, but it's also good at going and, you have to use these tools sort of introspectively. You have to get them to go back and look at what they've done, and that, and even doing things to sort of say, do a whole app audit and look for these particular types of things, these particular types of errors. And that was astonishing to me, you know, like the amount of things that it found in the code that I'd written, like that it picked up and went, oh, actually, you know, there's dead code here and there's a bit, you know, and this should probably be done a bit differently. I've actually been finding that quite surprisingly useful. And I think, I know, like I work with a bunch of people, obviously some of them are very much sort of Claude pilled and others are very hesitant to use the AI tools. But even the people that are hesitant to use the AI tools have found it very interesting to use them in a non-generative way. So in terms of that sort of code introspection, you know, auditing your code base. Yeah, that's right. Yeah, looking for solutions to things. You know, like if you'd asked me, you know, 6 months ago about this, I would have been skeptical. And I have had my opinion changed. I actually think that using AI to build code is not. It's real. Like it's definitely building real code. It's building a lot of good code. You know, obviously there is a bit of a load in terms of reviewing it. I guess what happens though is that the more you use it, the more you trust it. Like if it's continually producing code that's working, then it gets easier to just go, oh yeah, we'll have done that correctly, you know. And certainly doing things like getting it to do your commits, you know, and doing pull requests and generating all the changelog output and things like that. You know, as long as you've got tooling around that, you know, you might build a skill for doing a, you know, ship or something like that, which has constraints around how a changelog is built, you know, because when I first started using it, you just say build a changelog. Well, you might do it, but it'll throw in a whole bunch of things like, you know, changes that are only relevant from a development point of view, like refactors or, you know, things like that. Like the user doesn't need to know about that. So you put in a line that says something like, you know, only mention user-facing changes, be concise, don't write a paragraph for every single thing, you know. So I guess sort of like getting to know how to use the tools well and develop sort of the right sort of I guess sort of prompts around it. Yeah, I still end up using it for doing like I still end up doing a bunch of user interface tweaking with SwiftUI. You know, I think it's often faster to just go in there and just make things the right font and, you know, so on than it is to prompt it and hope that it gets it right. Having said that, I was just telling Alex that today I, for the first time, used Claude Design and I took a whole bunch of screenshots of this app and I threw them in there and I said, this is what the app does. Can you provide some design advice, you know? And actually what it threw out was really interesting. Not only the textual advice, but it then also created a bunch of mock-ups for me. And, you know, looking at that, see, you know, this app that I've built has not had a designer because it's really just an internal tool. And so for me as a developer, it was actually great because it was like, oh, actually that makes a lot of sense, surfacing that, you know, there and making that font bigger and that font smaller. And, you know, why are you doing the grid like this? It should be like this. That was actually really helpful. I mean, I'm sure a real designer would probably do a much better job, but, you know, it allowed me as a pure developer to rework the design in a way that greatly improved the usability. So, yeah, look, I am very much now thinking, holy crap, this is real. It's not just a flash in the pan. I agree with everything you said about, you know, the costs of things going up. And I think that there is going to be a correction and that everyone's going to be potentially in trouble because they've been relying on it to do all their work for them. Because there's a different set of skills. You know, you're not really developing in the sort of traditional sense. You're kind of building things and guiding it. And that is a different skill.
Yeah,
you know,
100%.
You still need to know what you're doing and you need to know how to guide it. until what API endpoints to look at. But yeah, gosh, I've been so impressed. I'm sure it is not great at a lot of things, but yeah. Anyway, that's my experience.
Yeah. No, I think what you touched on there about the retrospective is how can you incorporate this? Oh, I made a mistake here. How did it correct itself, or getting it to correct itself so it doesn't make that mistake again? Like one thing I've been using it for is a migration. So our app is close to 1 million lines of code, so very big. I'm refactoring one module, which is 70,000 lines of code.
Yeah.
Would I be able to do that with AI on my own? Absolutely not. Like, this is an app that has 30-something engineers, like, on iOS, like, pumping features. Like, there's no way you could do that on your own. No. And with AI, I've been, like, superpowered to do that. But it doesn't get some things right. But, you have a first crack at V1 of the skill, and refine.
Yeah.
And then now that skill's working after, like, the fifth or sixth iteration, working, like, really well. And all the sort of edge cases that are popping up are now starting to be baked in. So it makes a decision based on what I want it to do, not what it thinks it should do. And that's where I'm saying, when you can tie it into an iterative loop, same as if, say, you're building something and it's like, does something wrong in terms of accessibility or layout, tying that into your actual skill so it doesn't make that mistake again. I think that's when you get that learning loop, it gets really powerful.
And I think also, even simple things of sort of saying to it, if you're unsure, ask me a question, to clarify.
Yeah. Rather than burning, a few 100,000 tokens and then, that's not quite right, and it's to go and redo all of it.
And Claude's got some interesting things, like there's a insights tool in Claude that you can use, and that produces a really interesting report based on the way it thinks you've been using the tool and suggestions for how you could improve it, including, things that you can just dump straight into your claude.md file and things like that. And I've found that that's really helpful to run from time to time, and it does find things. It's sort of like, you keep, you've run into this scenario a few times. It would be helpful if you had a skill that did this.
Yeah. That's awesome.
Things like that. Yeah, I mean, it's impressive stuff.
It is. Cool.
Yeah.
Well, we might leave that there, and I'll hand over to Gotham, who's going to do a DC recapped. Here you go, sir.
I'm going to guess it's the extended display. Yeah, cool. All good? Yeah, cool. Sorry, the presentation theme is going to kind of go down in quality. So, hello everyone. So my name's Gotham. I'm a staff engineer here at Entain. I'm just going to be doing a quick dub summary. But before we get started, just something that I've noticed. Apple used to make some pretty nice animations during their dub developer sessions. But they've been kind of lacking the past few years. So I was kind of hoping that they'd do something more creative this year instead of just changing the background color. So you can just see like, dub 24, just a blue background, some text. 25 last year, just purple background. So I was hoping for a bit of a surprise, but they just changed it to orange. So to be honest, it's kind of disgusting orange. I feel like they could have done a little better. But look, if it's good enough for Apple, it's good enough for this presentation. So anyway, so the keynote this year was quite short. It used to go for 2 hours, with each platform getting their own time slot. But they really, just showed performance improvements and parental controls and Siri AI and, nothing much more. And a lot of people have been calling it like the snow leopard of releases. But if you actually dig in a little bit deeper, you'll find that there's quite a lot of functionality that's, just beyond just your app launches faster. So there is this YouTuber who is called Brandon Butch. or Butch, not sure, who does what's new video for every version of Apple's operating systems, including all the different beta versions as well. So like next week, if Apple puts out beta 2, he does like a comparison, like what's changed between those as well. So it goes in quite a lot of detail. And when there's like a major release like this, he covers a lot of changes. So they can get quite long. And I think the iOS 27 what's new is actually longer than the keynote itself. So it's quite an interesting watch if you're into like figuring out what kind of new features there are, because there's a bunch of stuff that Apple doesn't even show on their release notes. So he kind of goes into like the really like nooks and crannies of the operating system to find out what's new. But for this summary, we're just going to be focusing on the main changes for our developers. And if you have any questions about what I mentioned upcoming, I probably get better answers on Google because these APIs are new, so I probably don't know all the answers. So starting off, we're going to go with non-negotiables. So these are going to be things that's probably going to be affecting all of us, no matter what app you're kind of working on. So starting off is going to be the liquid glass is mandatory, and all apps must be resizable, and the UI scene lifecycle is going to be now required if you're on UIKit. So liquid glass, so the opt-out doesn't exist anymore. The info plist property, the UI design requires compatibility, doesn't do anything. So as soon as you build it with the new SDK, your app is going to adopt the liquid glass automatically. And following the previous App Store submission SDK requirements, building on the new SDK, which is going to be Xcode 27, that's going to be mandatory, probably going to be around April 2027, just like the Xcode 26 being mandatory in April, and the same the year before and the year before. So following the pattern, you're probably going to be required to build with the new SDK if you want to do any submissions after April next year. So it's a good time to audit any controls, the contrast, any custom UI components that you guys have. Apps must be resizable. So apps need to be able to handle arbitrary sizes. So of course, iPad has the multitasking already. And if you guys have seen Golden Gate, which is a new release, on the iPhone mirroring, you can actually resize the iPhone mirroring, which you couldn't do before. So you can see on the right side, this is the new device hub, which replaces Simulator. It's got a bunch of controls on the sides of the device, which you can drag to kind of change the layout. And I don't know if you can see in the bottom, it might be too small, but there's like a points numbers that you can enter for the dimensions. And you can actually just enter a custom dimension or ratio, so you can check those as well. And the UI requires full screen. Info plist is deprecated, so you have to use the UI scene size restrictions instead. But even then, not all of the behavior might be possible with the requires full screen. So you guys might need to check out your own apps to make sure that it's all working good. And yeah, we have to lay out by size classes, not by device, idiom, or orientation anymore. UI scene lifecycle is now required. So this is the app lifecycle being deprecated, and we have to use the scene lifecycle now. So yeah, UIKit apps without the UI scene delegate is not going to launch anymore if you build it with Xcode 27. And don't assume a single UI screen.main anymore. Better use the one below that, which is a Windows scene.screen. Cool, so moving on to Apple Intelligence. So they've got a few new stuff. So first one is going to be the multimodal foundational models. So you could already do the language model session already, but now you can actually attach an image to it. So this can be a UI image, NS image, CG image, CR image, or the CV pixel buffer or a file URL. So you can attach that as part of your prompt and get a response. Private cloud compute in a single line. So on-device model is at the top there, the first function. So you just create a session, set the model. You can set it to default, which is just going to be the system language model dot default. And this has 8,000 context on iOS 27. But they have a new private cloud compute available. So you just create a model object, pass that into the session. So second function there that you can see. And of course, you can also set the reasoning level as well. So we've got three options at the moment. So you've got light, deep, and moderate. And this one has a 32K context, and the reasoning is on the server side. And it's free for apps under 2 million first-time downloads, which is pretty generous. And it is per user daily limit. So there's no API keys or no accounts. It's all based on individual users. And they can raise that allocation if they have a iCloud Plus subscription. And the last little piece of code there, that's the structured output. This, I believe, is already available, but you can use the structured output with the new private cloud compute. So you can request the response to be in a certain structure, and you can use the generable, the macro there. And you can also guide individual properties so that the response kind of matches more of what you're looking for. Pluggable LLMs. So this is the new language model protocol, which means that Anthropic and Google can ship Swift packages for Claude and Gemini. I haven't seen OpenAI bring out their version yet. Maybe they haven't been told, because Claude and Gemini really put theirs out within like a day of the keynote. So, but maybe I could be wrong. I just haven't seen it. So this is the Claude's version. And you can see it's quite similar to Apple's own language models. You just initialize the model, create a session, and just prompt away. And the Claude's version has the name, property, and auth that you can pass in. Yeah, someone mentioned Fable earlier, so that's actually not available. I put that in. So it's actually just limited to Opus at the moment, but I don't know, maybe you get to see Fable someday coming back. So Swift UI stuff. So there is likely going to be a free performance improvement on rebuild. So state is now a macro. So reference type initial values is created lazily, like once per lifetime, not on every re-init. So your out observable models is probably going to be stopped getting thrown away every time the parent has to re-render, which is nice. Async image now does standard HTTPcation, which is good because we had a lot of troubles with it. So that's good. Drag, drop, and reorder. So you can just apply a reorderable modifier to basically any container, to like a list, scroll view, grids, to get like a free drag and drop functionality. And this works on the watchOS as well for the first time, which is nice. And you can also get the swipe actions to work outside of lists by the new swipe actions container modifier in SwiftUI. Adaptive toolbars, which you can see at the bottom there. This is the same code, but one's on the iPad and one's on the iPhone. So you can actually choose priority levels for different buttons there. So as you resize the app, it'll automatically adjust. So if you want to make sure that, say, the back and forward buttons that you can see there, if you want to make sure that's required to always be shown, then you can do that. If you want the delete icon to be kind of hidden away if the screen is too small, you can set that preference as well. And document architecture. So this is the new readable document and writable document, which replaces the file document. And the main takeaway, because I haven't looked into it too deeply, but the main takeaway is going to be that every edit, reads, and writes can run async off the main actor. So compared to file document, which I believe is synchronous. So it's pretty nice. So Xcode 27. So coding agents are first class. So Xcode Assistant is going to be agentic. So there's going to be a separate chat window. You can group conversations. There's a plan mode. You can edit the plan. You can ask clarifying questions. There's also automatic documentation searching, so it cites the latest APIs, which is good. And as before, the tools can come in through the MCP, but you can also add a custom agent in the settings through the ACP, which is the Agent Client Protocol. Xcode 26 should already have this now. I think it's 26.6 should already have it. And as mentioned before, the Device Hub replaces the simulator. And of course, it's got a bunch of new features as well. And if you have Xcode 26 simulator and Xcode 27 Device Hub open at the same time, it goes crazy. Like the devices just freak out. So probably have one open at one time. Reworked workspace. So there's a minor UI refresh. There's some new themes, which is quite nice. You can also create new projects without having to type in the bundle identifier and the project name. So if you want to try out a new API, you can literally just create a new project and just type away. And you can, if you want to, when you close it, it'll ask you to save it, or you can just delete it. So a lot quicker to get started. And there's also a new playground macro, which you can use to do quick experiments, so you don't have to create a new playground file. And Organizer adds a new storage and hitch metric, so you can kind of see there, probably screenshot's too small, but yeah, that's the hitches metric. Ours is perfect, so there's no hitches. So testing, performance, and diagnostics. So there's a WWDC session where you can migrate to Swift testing incrementally, and they can also live side by side because it's interoperable now, which is nice. New instruments, so this is the instruments 27. There's a new profiling tools for foundational models and also for Swift concurrency, so you can visualize the queues and running tasks as well. So that's just a bit of a summary. Of course, there's a lot more. There's new changes to Swift data, Swift 6.4, app intents with the new Siri AI and App Store changes. And these could be their own talks as well. So Adam's on the hunt for anyone that can talk about any of these. So, and that's all. Thank you so much. Going to hand it back to Adam.
Yeah. Sweet.
I just wanted to watch until the end.
How's the audio?
Good.
Perfect.
Question, I don't know if you've dived into it, but around like the migration to scene, I didn't actually catch that. To use the scene delegate, but do you have to support like multiple instances of your app side by side, or is it just?
I haven't seen that far, but
Yeah.
the app delegate, those life cycles are probably kind of dead.
Dead in the water.
You can still be in a single scene. Like you can.
You're not forced to have multi-scene support.
Yeah.
Okay, because I was like, it's quite a big
Yeah.
jump for a lot of apps.
No, it's
Would it be
pretty-
surprising if it's coming soon though, right? With the foldable stuff. It's like there's a screen on the front.
Yeah, but like having two instances of your app potentially
Yeah.
next to each other. Kind of
Yeah.
thing.
Like read like notes and notes. Or
There's
something
like
else.
multiple windows.
Yeah.
when you split screen.
Yeah,
Yeah.
so it'll catch a lot of people out when they force your hand with that, I think.
Can't really see that happening.
Mm.
I mean, like it wouldn't make sense to have two instances of a game next to each other.
Mm.
As a user, it'll really just. I always get incredibly confused when I start with Safari's big
Yeah.
open
Yeah.
and stuff.
Mm.
Where enable
The tabs from Gavin's got the application. Well, yeah, the rest of it is
I did it,
tabs.
I think the last one. Yeah, because I'm on the phone, it lets me do that.
Yeah.
Which is a bit annoying. Because some of the beta was normal, which is literally just kept saying,
Plus the mix and stuff is going to make a lot of apps. Bunch of reaction.
That's the magnet that goes inside your t-shirt.
Awesome. Oops. My password is required.
Yeah, well, if it runs on it, it should.
Imagine a crazy thing like, if you get it to work on the phone, then
Extended
that will
display.
be able to put it into the dock, and the phone-sized version of it.
Beautiful.
Well, yeah, it'd be interesting to finally break out of running an iPhone app on an iPad.
Right. Might be a bit disappoint you, but I won't be talking about the Metal API much. And I'll be more talking about the techniques I actually used and anyone will be exposed to if dealing with real-time render. And I think that will be much more helpful for you because the API can be learned using the AI if you want easily. But those render techniques, they are really things you have to basically learn over the time, and you basically build up your knowledge around it, and you can use in any basically API. But I picked Metal for the reason I'll tell you why. So let's start a bit further back. Last year, I've been invited to participate in an interesting project, and I'm building water fountain. It's not very iOS, but still. And the hardware side was familiar to me. It was like the electronics was able to control many pumps, lights, and it was very easy to me to address any light and any pump and make it basically run at any speed and turn on any RGB, whatever. And actually, it's been used for a while, but the scale of fountains before that was very small, like 8 pumps, 8 lights, or something like that. This time, the fountain was incredibly huge. It's like 400 lights, 400 pumps, and it needed to be orchestrated sort of properly. And I went like, okay, I'll build a script which will, because the fountain was like a grid, a script which will do some mathematical simulation, then export everything into my hardware, and we'll be playing stuff, and end of story. But the thing is that I have to somehow debug that thing. I want to watch how it'll look like, because they eventually, and that's the unfortunately only video I've got, right? This was the fountain. It was really, really big, and it needed to be sort of played like and orchestrated properly, and it was not feasible to go there and debug the stuff there, other than just debugging the wiring and connections. Yes, I mean, to the extent you have to debug, but you cannot just go and then compose like, hey, I want this and that, just turn on and off and stuff. So it quickly became clear that I needed sort of a simulator. And I think it's worth explaining why Metal. And I didn't choose it because I wanted to make the stack as low as possible and complicated. And the target environment, the thing is that the target environment was already Apple. And I had previous Metal experience from 2000. I mean, with the GPU, I had experience from 2011, and then later Metal. And another point why I picked the Apple ecosystem, inherently Metal, is because I wanted to come over to this site, take the iPad, and show actually the end customer how it'll look like. So the customer can basically rotate the fountain and see how it'll behave, and play it back, rewind back and forth and stuff. So Metal became sort of an inevitable. So what came out of it? So the original goal was very practical. The app is not a script editor. It is just a preview, which, you design the script anywhere you want, and the script actually is JavaScript. And the preview updates as soon as script changes. It basically looks after the updates in the folder
But while building the simulator, you know, the visualization went a further than I initially thought. Spoiler, much further. And it became not just a technical preview, but real-time sort of visual simulation with particles, lighting, transparency, reflections, and ripples. And I want to explain the rendering techniques behind that. The first thing is that the particles, the water fountain is based on particle systems. It's obvious when you want to simulate water, it's much more easier to think about it as particles. And the idea was to not control every particle directly, and like not tell the renderer like, hey, I want particle number 123 to stay there, a drop of water appears there and there. The idea was intense. So you describe like the origin, the like pretty much position, the direction, the initial velocity, and or height of the stream, if you like, depending on how you want to describe, and like and that's sort of a bridge between the sort of a language and of show and the language of real-time graphics. And the particle in this you know, scheme, it needs to be cheap. It should not contain complex water model, its own like material and like history of motion and everything, and like it just contains its current position, like here. That's a pretty much very simplistic structure what I use in metal, of like how the particle is structured. So what I did there is I computed the actual height of the jet. It's quite simplistic way of computing things, but that's okay because that's enough. And everything about the graphics, when you go in real-time rendering, you have to be very careful about what's enough to achieve a particular result. Otherwise, you end up with a very, very slow speed. So it's not full-field simulation, but it's just an artistic simulation which works very well. Now, the particles are getting updated every frame, right? See, gravity changes velocity, and the velocity changes position, and particle goes, if the particle goes beyond, like below the ground level, it needs to be reflected, and the reflection should be better not be like a perfect mirror reflections, but rather having some noise in reflections, like randomness sort of, to simulate like if this was a sort of a real water. Next, so now interesting sort of things. Yeah, so as soon as a particle basically hits the ground, we change the sign, and then we basically apply some random factors to coordinates to make it basically jump off the ground in a random way. Now particles, all right, I mean they're flying, cool, and how about the life cycle of the particles? There needs to be somehow be born, then alive for some time, and then basically recycled. Here is the trick. On a GPU, we don't have such a thing as allocations, right? We have pre-allocated array. We never allocate memory, and deallocate memory is very expensive. You have allocated array, which contains, it's a particle buffer. And also, you have list of particle indices, which basically a pool of indices available to take and use in simulation. As soon as the particle dies, it returns back to that list. And that list is changed atomically. The thing is that because of the GPU parallelism, all the particles are flying, so I mean calculated in parallel, but when time comes to return it back to the pool or take it off the pool, it needs to be atomic. And that's the only atomic computation here, and that's sort of a bottleneck, but sort of acceptable because we're not atomically access this huge array, but we access only 1D array of indices. Now, all right, so the life cycle is more or less, I mean, in a very simplistic way, I'll explain it, how it works. Now, lighting. So what challenge actually I faced with, imagine if we've got 1 million of particles, 400 lights, and every single light is cone. Meaning that if we naively go and calculate the elimination of every single particle, you basically end up with 4 million calculations per frame, 60 frames per second, about 24 billion of calculations per second to make it work, and it won't fly. I mean, it will be dog slow. So what was the solution to do that? The solution was to calculate light separately, and then make particles to go and get that pre-calculated light somehow. And they called like a 3D light texture. So what happens is we take those cone lights and bake into 3D voxel space. And then once we do that, the particles just go through the voxel space. Basically, what we do, our scene is surrounded by a bounding box, right? We have a bounding box, so we can map our 3D texture to that bounding box, and we have to carefully find a right resolution of that 3D texture. In my case, it's like 520 by 520, and height is 16 only, which is reasonable if you like. The total amount of memory is reasonably low. Yeah. And the particle flies through the volume, basically fetches at constant speed, fetches the light, like this. So this is a bounding box around my fountain, and the particle goes through it and just basically very, very cheaply fetches the light out of it. Now, question, how to bake cones into that 3D texture? We basically do sort of an MRI of the cone. We have to split it into layers and get a cross-section of our cone, because we treat our cone like light as a geometry. And we want to split the geometry into a section, bake into the 3D texture, and then use that 3D texture for particles to fetch that data from. So basically what happens is that, yes, we go through slices and only draw on that particular level. So what we do, but before we go into how we bake it, let's talk about how we render the actual cones irrespective to the technique of baking the cone into the 3D texture. So the cone is approximated with triangles, right? Faces. And so basically we have some cone base, we split into the segments, and segments are, probably all of you in the very beginning of your software engineering writing program life, you were drawing the circle. When you draw the circle, you just go x, y, plus radius times sine or cosine, angle, and do some angle increments, and basically draw the circle. We do very much the same, but our increment is just 1 divided by a number of segments. Why I'm talking about that? Because we are not preparing mesh in advance. Like, this is not being prepared in advance. Instead, we send all the vertices to the GPU and go like, hey, draw the not a draw, but rather find yourself which vertex belongs to which triangle and what triangle we're drawing right now. Yeah, so on a CPU side, what we do, we just pretty much send the command to GPU to draw n number of vertices. For 16 segment cone is 48 vertices. So we go like, hey, draw a 48 vertices. And nothing more than that, because GPU will be deducting from the vertex index, it will be deducting the index of triangle and index of the actual vertex. Here, this is a vertex shader. Let's look into what's happening there. It receives the vertex ID. If we divide that vertex ID by 3, we get the segment index. If we get a modulo 3, we get a triangle index. We basically corner in we get a corner inside a triangle. And if we divide it by 3, we get the triangle index. So we can deduct in a shader what we are dealing with, which triangle. So yeah, so we basically throw vertices to the GPU, making GPU to compute all those vertices and pass it through to the pipeline further down the pipeline. That's the first sort of technique I'm using, which saves me a little bit of the bandwidth. I'm not preparing the mesh on the CPU, not sending that mesh over to the GPU. I just ask GPU to draw 48 vertices, and it magically turns into a cone. Next thing to talk about before we return back to how we slice those geometry figures into 3D texture is winding. What happens when the GPU draws a triangle? It goes like ABC, next triangle ABC, next triangle ABC, and sooner or later you end up with a triangle which lays on the back side of the cone, which will make the ABC turns into CAB basically. And when rasterizer will receive those ABC or CAB different orders, it can distinguish which are clockwise and which are counterclockwise. And you can instruct GPU to draw only clockwise, draw only counterclockwise, or both. So it means that you can, for free, for very cheaply, ask GPU to not draw the back faces if you want, or other way around. You can ask GPU to draw only back faces, not front ones. That's an interesting technique, because imagine if you could draw the front faces and then subtract the back faces, and you end up with the cap of the cone, right? Like blending, you will draw the front, this, and then subtract the back faces, so you end up with a silhouette of the cap of the cone. That's something we have to keep in our mind, because it will be used in the baking technique. And the last but not least is how actually pipeline works in a GPU, just to have an idea. So the vertices are coming to the vertex shader. We do something with them. In our case, we basically calculate their positions as if they were a cone. Then it goes to through the those triangles go to rasterizer, and the rasterizer will basically send those fragments it generates into the fragment shader. Previously, in a very old GPUs, back in the days when there were no vertex and pixel shaders, there were no vertex shader. There was just triangle assembly, rasterizer, and blend unit. That's pretty much it. So it means that you could back then only prepare triangles in advance, send it to GPU, instruct GPU in a very limited way to draw triangles this and this, differently. Nowadays it's very flexible, but my point is that old part is still there. You can still use that color combine unit, which basically came from the old pipeline. This combine unit is very helpful for us because that's the one which will be either adding or subtracting pixels from the render target. The render target is basically the final texture where everything is getting drawn to. All right, let's go into the actual how we going to bake our cone. Imagine that we've got a cone and we have a particular slice texture, and we want to get this kind of cross section, right? What we do, we set up camera, like a temporary camera, in a way to look from up to down, like to bottom. And in front of the camera, we set up pretty much square texture. That square texture will be the slice of our, like this pretty much slice of the future 3D texture. It's where we're gonna draw stuff in too. Next, we can definitely determine which faces are front for the camera using the technique I explained before. And we set up our renderer in a way that we setting the culling mode front to avoid drawing the back faces. So we draw only front faces. But in a pixel shader, in a fragment shader, every time we draw something, we check if the height is below the cross section or above the cross section. We don't draw anything below the cross section. And if we take this as a texture values, we can see how the front faces contribute into the texture. So pretty much we get very long cross section, more than we need. Then in the next pass, what we do, we instruct GPU to draw only back faces. And again, we're not drawing anything below the cross section by checking the depth of the fragment. We actually know the slice. The slice is our depth. So we can, every time the fragment shader draws something, it receives the, I mean, you can examine the depth of the pixel, like how deeply it is in world coordinates. And if it below the cross section, you can just discard it. So that's what we do. And our back faces, they actually subtract data, meaning that our previous contribution, this one, getting subtracted by a new contribution, and we get exactly the cross section we want, right? Or is it clear-ish? Right. And every fragment, when we draw that cross section, that's a side view. That's a view from this. I mean, I forgot to mention that. That's a side view. So in every fragment we draw, when we draw that cross section, we can get an X, Y, Z, and for sort of very cheaply compute the radial fall off and axial fall off, and we get a proper attenuation of light in every single cross section. And look into how that fall off works in the real. So we get properly attenuated light. That's a sort of a searchlight example. Now, when we have those slices combined, they are forming so-called 2D array texture. The 2D array texture is a great thing, but it's not great for fetching colors from it because it gives you bilinear filtration within the slice, but it doesn't give you cross-slice filtration. By filtration, I mean like interpolation of the colors. So that 2D texture needs to be copied as one of the extra passes, copied into the 3D texture, and that one needs to be used in actual scene. I will after the presentation, I will jump into the Xcode and show you how the frame is built. Right now, the particle size and camera. Every time you draw a particle, the particle itself, from the GPU's perspective, it's point sprite. The GPU has a notion of point sprites. The point sprite is pretty much two triangles built for you for free by GPU. You're not really thinking about them as two triangles. You just think about it as a point and its size. And it's always faced towards the camera, which is, again, done by GPU for free for you. And all you need to do is to compute the distance from the camera to the point to get it, to adjust its size. So the further points are, the smaller they should become, and the closer they are to the camera, they are bigger. I mean, that's how the perspective works here. Another interesting sort of challenge was GPU is drawing those particles in parallel, meaning that particles can be drawn out of order. So you can end up with drawing very close particle, and on top of it, end up drawing something very further away, and you get improper transparency and proper order of draws. Ideally, you need to have those particles ordered from camera backwards and then or other way around to get a painter algorithm. So first we draw something from in the back, and the last particle is closer to the camera. But I actually implemented that, and it was very, very slow because sorting 1 million particles, you can't really fit into one frame. You have to sort it through, spread the sorting over like 10 frames, and it looks very weird. Like you rotate the camera, everything very spoiled, and it gradually returns back to sort of normal. And if you have a camera which moves, you always end up with a mess on the screen. In 2014, there was an article explaining how to work around that. It's called weighted blended order independent transparency. So the idea is very simple. We have two buffers. First, we accumulate how much color we've got, and the second one, we accumulate how much background we've got. And in a very big end, we just divide this by this, and that's pretty much it. I mean, very efficient way how to draw stuff in a sort of sorted way. Reflections are surprisingly easy. All you need to do is just to rotate the camera around its viewing axis, draw the very same scene again, and then draw the actual scene on top of that. And that's pretty much it. You get reflections. Now, ripples. Back in 1998, there was a ripple algorithm. That's an actually C code. Back then, the VGA resolution was 320 by 240, and what do you do? You just add some. You've got some, sort of a height map, so-called texture, or back then it called like buffer, screen-sized buffer, and what you do? You just add some noise and that loop constantly running through that buffer, dumping that noise, and it becomes a sort of a ripple. And if you keep adding noise, you get like a raindrops or something. You can add noise after the mouse cursor, and you get this kind of effect. Very old one. It actually been published in demo scene, one of the very old demo scenes. But it's highly parallel and can be used on the modern GPU quite efficiently. So why this scene feels alive? This is actual render. Because no single part is complete simulation of water. Like physics create motions, the light volume creates volumetric color. The transparency, the weighted blended order independent transparency does its job to draw everything is in right order. And reflections and ripples, everything gets you helps you to build a convincing image. So it's pretty much everything is fake. You are not really computing real fluid simulation. All you do is just pretty much compose different techniques and as much as efficient as you can render them on a GPU. Now let's jump into the Xcode. How to? Yeah, here we go. I think that I'll need to. Oops. Right. So. Million particles, almost 60 FPS. The water fountain. Yeah, you can like move it around and stuff like that. There was let me show you a searchlight. Oops, here we go. This is a searchlight I was showing you, right? And let's jump into its frame. Light map. In particular, the 3D texture with. So this is a bottom slice. We can switch slices here and get pretty much an MRI of our cone with the radial fall off with the proper attenuation of, like you can see those little gradients on the edges.
Little conic section.
Yeah. I've got only 16 layers because I have to be very careful about the resolution of the 3D texture. You can increase, but it'll be very slow. Right? There is very interesting to look into other example I did. This fountain. Yeah. So this is the outcome of it. It has many lights, and you see those lights, they can perfectly overlap. And if we change, we can see how this is a topmost layer of the fountain. Not too sure if it will display now. It won't display simultaneously the output picture and So it blends perfectly. I mean, many lights can be blended perfectly. Let me. Yeah, so we do multiple steps here. First, we prepare our light map. First thing we do, we work on those ripples. We just clear everything before the frame starts, and then we draw the actual light map. We bake cones there, rasterized lights. So we draw like a primitives, those geometry. Those are cones. I mean, they are flat because they rasterize, or it looks at them as the very flat structure and not volumetric. That's the first step. The second one, then we go the actual frame render. We simulate particles, like million particles. Then actually, I didn't talk about the global illumination approach. So what I'm doing, I'm actually building another 3D texture where I contribute how many particles in that place to scatter the light across the, where the many particles are all together, they are better absorb the light. You can watch into that. This is like where, oops, no, those are ripples. Those are where we got more particles and less particles. This again, this is a texture like from top to bottom. Yeah. You may see. This is upside down. This is the reflections. Then we draw straight frame, and then we do a composite. The straight frame, as you can see, it doesn't have reflections, and the composite actually blends those together because I want reflections to be slightly dimmed. And here we go, and frame is there. And another thing is we can look into how busy is our GPU. Where's counters? It doesn't want me to show the counters. No, it doesn't want me to profile, unfortunately. Yeah, I wanted to show you how it profiles. No. I think that's because I built and release build just to make it faster. It doesn't display my counters for some reason. All right. There was probably wrong place. Yeah, here we go. Performance here. Was looking into the wrong place. Wrong area. Just wait a bit and you will see the occupation of GPU in within the frame in different points of time. So this is how a frame of the GPU is allocated. So the light rasterization is 1.18 millisecond. Like drawing the reflections 1.33, drawing the straight picture 2.28 and stuff like that. What we can do here, we can debug and you can check what is the bottleneck and what needs to be optimized, what needs to be computed in parallel, and where your GPU is doing nothing, and you'd better reshuffle stuff to make it work as much as possible. So now one frame takes 6.8 milliseconds, which is within our budget, 16 milliseconds per frame for 60 FPS. Yeah, and we can see what's allocation, what's the cost of every single stage. And here you can see how much fragment shader takes and how much vertex shader. You can see the bottleneck here is definitely the fragment shader. Jump into the fragment shader. And you can see exact profiling of your shader, how much percentage time is taken in a particular line of code. So you can drill down to the actual figures, what is taking much time. That's pretty much it. Thank you very much.
I have a question.
Yeah.
Are you achieving the changing of colors, because I saw the colors were like kind of spinning? Are you changing what each point of the world is like representing the color? Is that what?
Yeah. What I'm doing there, I'm setting up those cones, and make those cones basically rotate.
Oh, okay.
And that's it. That's not real. I mean, in real life, your cones will be static. In real fountain, they'll be static, and you have to be switching between them. But I thought just rotating is visually more appealing.
And so those individual like water droplets or sprites, do they collide with each other, or is it just?
No, interparticular collisions, they are sort of very expensive.
Yeah.
And I thought I'd better increase number of particles at cost of making it. It's a trade-off. It's always about trade-off. It's very, very computationally intensive thing. Mm.
Cool.
So you said you're doing scattering? So there's another 3D texture, which was the density of particles in any area, and that was how much the colors got scattered, right?
The texture is relatively low resolution, and every particle flying through the particular voxel, contributing to that voxel like +1, +1, +1, and you end up with the voxels with different density.
Okay.
And what it gives you, other particles can, when particle flies through the light, it can multiply that light by the density in that voxel, meaning that particle will glow much brighter. And neighboring particles which are close and in this voxel area will be eliminated, much like a little bit brighter, so giving you an sort of an impression that the neighboring particles are helping each other to.
So it's like the neighboring voxel is a different color, and the more dense that voxel is, the more it is counted by its neighbors, because you got to be scattered from a.
It's just a multiplier, just a factor.
So the scattering is only within one voxel.
Yeah.
Oh, I see. Okay. So one thing that you don't do is, like, if the floodlight is going through an area of high density, there's no like shadow. The water doesn't cast a shadow.
Yes. Yeah.
Which is fair.
That's the thing.
That's
a deliberate.
It didn't make the
decision.
cut. Just not important enough to spend your precious compute on. Yeah. Okay. Cool.
Yep.
A couple of questions actually. What did the client think of this?
Oh, they were impressed.
Yeah.
They were impressed. Actually, that idea, it came from the very old times, back in 2000, maybe 10. I was trying to build the very same thing using DirectX on Windows, and I did it. And it was times when shaders just disappeared. It was GeForce 3. Yeah, but it was way simpler than this. Yeah, less powerful, and number of particles was like 50,000 maximum, barely 30 FPS. Now it's like million, and it's 60 FPS, and it has much more. It has extra time. It's just basically idling.
Yeah.
Yeah, yeah, and it's M1, and imagine what will happen with like, yeah.
Yeah, nice. And I saw the particle had a state that was called mist.
Yeah, I did a mist simulation. The thing is that the client's fountain had high pressure mist systems. So the designer's idea was to turn on the mist and together with jets to make that fancy effects. And the mist, those are huge points price with the texture, like pretty much a radial texture with transparency on edges. And if you draw it like many sprites and make them semi-transparent, you end up with having a sort of fog or mist.
Yeah, right. Cool.
Yeah.
So did they actually use that?
Yeah.
Yeah. Yeah. Right. Cool.
Yeah.
Amazing. Anyone else?
Yep. That's pretty much it. Thank you very much.
Thank you. Brilliant.